Here's the problem. Two-sum LeetCode problem. Two-sum. You are given a list of numbers and a target value. Your job is to find the two positions whose numbers add up to that target. In our example, the list is 2, 7, 11, 15, and the target is 9. 2 sits at index 0, and 7 sits at index 1, and 2 plus 7 equals 9. So the answer is indices 0 and 1. The approach is a single pass hash map. Here's the idea. As we walk the list, we keep a dictionary called scene that maps each value to the index where we found it. That dictionary exists so we can look up any earlier value in constant time. For each element x at index I, we compute need, which is target minus x. Need is the exact partner that would complete the target, so if we ever see it, we are done. The key line asks, is need already in scene? This is the whole trick, because a hash lookup is constant time on average, far cheaper than scanning the list again. If need is present, we return the stored index of need together with the current index I. Otherwise, we store x under its index, so that a later element can find it as its partner. Now let me narrate the capture dry run on 2, 7, 11, 15, with target 9. Step 1. I is 0, x is 2, need is 7. 7 is not in the map yet, so we simply store 2 mapped to 0. Step 2. I is 1, x is 7, need is 9 minus 7, which is 2. And 2 is already in the map at index 0. This is the moment the answer appears. We return index 0 and index 1. Done in a single pass. Let us derive the time bound. We make one pass over n elements, and inside each step we do a hash lookup and a hash insert, both of which are constant time on average. So the total work is n times a constant, which is order n. Why is that optimal? Because you must at least read every input once to know the answer. So order n is a hard lower bound. Nothing can beat it. Contrast this with brute force, which tests every pair. That is n times n minus 1 over 2 comparisons, which grows as order n squared. Concretely, at 1,000 elements, the hash map does about 1,000 steps, while brute force does about 500,000. Now space. The hash map may store up to n entries before it finds the match, so extra space is order n. Brute force uses only constant extra space, so the trade-off is clear. We spend order n memory to cut time from quadratic down to linear, which is well worth it. The returned answer is just two indices, constant size, so the map dominates space.